Today we're out here on the Jefferson Street Bridge over the Des Plaines River in Joliet, Illinois to complete a LiDAR survey of the existing bridge structure for a bridge rehab project that they're going to be doing out here in the near future. We're using a Leica P40 scanner. We have a lot of targets set up all over the bridge. Some are geo-referenced, some are going to be on known horizontal control. We're running a 3D traverse and also doing differential leveling to all of our control and take it in the office, post-process it. We're going to have a data cloud to extract all the key features that are needed by the clients. They're going to be doing rehab to the bridge. They're not going to be replacing it, but they have a rehabilitation project. Their primary interest is the track and the track plates along the vascular arm of the bridge. We're going to kind of see how it turns out. They're a little greasy and they're a little wet, but hopefully get some good data on it. And today we're going to talk about how we just go about collecting this type of data, how we're going to work with it, what we can take out of it, and why it's advantageous to use.
I mean, our clients span both public and private. Quite a few public clients, including IDOT and the Tollway. Tollway is a large client of ours right now. We're currently the suit provider for the Illinois Tollway. And you get into an urban area like Chicago, there's stuff everywhere. And a lot of the utility companies, they're getting much better at it. But a lot of the utility companies don't know where their facilities are at. You know, this is their assets. And sometimes we run into some base information that they don't even know what side of the street that they're on. So there's definite worth in paying for the suit process.
So part of the advantage of the LiDAR system is that it's giving you a 3D cloud. Everything that the scanner can see from its position, you're going to have a data point on. For example, on this site, you got a lot of traffic. You're on a moving bridge, there's shipping traffic, there's just regular car traffic. It's not easy to get up on that structure to take measurements, to verify locations, sizes of different beams and girders. And what this allows you to do is take this 3D world into the office, and you can pick and choose what you need, where you need it. You don't have to send a crew back out to the field if you miss something. You just got to open up your cloud data, you can take those measurements, and you can extrapolate any information that you need. And so the real advantage is not having to come back out. It's going to save you time, it's going to save you money. The way that technology is progressing, everything is moving into 3D models and 3D modeling. And this is a tool that's going to give you everything you need to make as-built models and then pre-designed models as well.
Typically in subsurface utility engineering, it is all of the latest surveying techniques are used by our organization. So we use kind of a combination. Primarily we use GPS, secondarily we'll use a total station, but then we can also use LiDAR in some situations. LiDAR is real helpful for us is when we're in a situation where we need to capture the topography information, but it's difficult for us to go out and capture that information. So what we'll do is we'll have it attached to a van, we'll drive through that area, collect that information, and then the real work happens on processing it on the back end. So we're able to collect the information very quickly, and then we spend more time on the back end, but we're not putting our workers in a hazardous situation to collect that information. The reality is that, if you're not testing out new things, you're going to be doing the same thing you've always done. And the more work we can complete in a day and the more accuracy we can have, it's going to make us more competitive in the market. So we're constantly looking at ways we can make ourselves and our workflows better.
We have done some interesting jobs with the scanner. We were contracted out to do the Superman movie, the first one that they came back with. We scanned the farmhouse in Plano over here because that's where they did the farm shooting. So we scanned the farmhouse and the silo and the barns and stuff, and they modeled that so they could blow it up in the movie. That was pretty cool. We did Comiskey Park when they wanted to see if they could fit a football field inside the stadium so they could play a Northwestern game there. So we went out there and scanned and see if they could drop it in. They really could not, unfortunately, so it didn't happen. Architectural scan on the Chicago River at Michigan Avenue, the Wrigley building, the Wrigley staircase down there, because they're rehabbing it. And so we scanned all the stones and That way they were able to put every block back where it was so they could match the original staircase exactly. We've used the P4D to scan the breakwater out in Lake Michigan and combine that with underwater multi-beam data, so we have a full 3D model of below surface and above water site conditions. You can pretty much anything, pipe work, go in construction sites for their piping. Anything else you need, you just open up that cloud.